Since courts require evidence be authentic and unaltered, the acquired digital evidence must be preserved in its original state. Forensics uses cryptographic hash algorithms to preserve evidence. Cryptographic hash algorithm is a one-way function that maps data of arbitrary size, like a message, to a fixed size bit stream, or called hash value. The same message always results in the same hash value. Here, one way means it is infeasible to reverse the mapping to generate a message from its hash value. A cryptographic hash should be a collision-free algorithm. That means it is functionally impossible to find two different messages with the same hash value. So, if we want to prove or authorize that two hard drive images are identical, we only need to calculate their hashes. If the hashes are same, the two images have to be the same, according to the collision-free property. One commonly used cryptographic hash algorithm is MD5, which produces a 128-bit hash value. Another one called the SHA algorithm was developed as a US federal standards and output a variety of hashes such as 160-bit, 256-bit, and 1600 bits. The lower bit hash algorithms like MD5 generate hash values more quickly, but are more likely to cause a collision. Researchers have found collisions when using MD5 and SHA-1 separately. Forensics investigators use cryptographic hash to preserve evidence. They also use hash to conduct a hash analysis, which will be covered later in forensic analysis lectures. Now let's practice cryptographic hash functions on a Linux machine and examine what changes will affect file hash value changes. Hi, in this demo, we will practice the basic hash algorithm MD5 and understand what changes will affect file hashes. Now, MD5 and SHA are free tools and are widely available for various operating systems. Here I use the SANS Investigative Forensic Toolkit, short for SIFT workstation. This is a free downloadable. The download instructions are provided in this unit's exercise. The SIFT workstation is created by an international team of forensic investigators, led by SANS faculty Robert Lee, for incident response and digital forensics use. It is available to the whole community as a public service. SIFT includes many incident response and digital forensics tool suite. I will use SIFT in other exercises for this course. Although it's not necessary you use this tool, you use this workstation, but I strongly recommend you to use this Ubuntu-based forensic workstation to practice Linux, Unix-based forensic tools. Here is my SIFT workstation. Before I start using MD5 sum, I want to find out where is this file located. This is important because if you have two MD5 sum, one is malicious, and you need to find out which one you are using at this point. So now we know this is in user bin, supposed to be a right place, and then let's create a new file to generate the MD5 sum. If you already have file exist to calculate MD5 sum, and then go ahead, and here I create a new file called file0 with the content of welcome. We can log into the content, and it is welcome. Okay, so now calculate MD5 sum. It's very simple. So we simply just say MD5 sum and followed by file name. So this is 128 bit of MD5 hash. It's a signature for file 0. So that's nice. Now we need to remember that MD5 sum, and then we modify content of file 0 to see whether the MD5 changes or not. So in able to remember that, so let me create another terminal so we can compare. So remember this, that's the top one. We still have the file 0. Now we modify file 0. So to modify it, simply I'm just adding something, append back to the file 0. So now file 0's content changed. What this looks like now. So file 0, now it's welcome back. Still called file 0, but the content's different. So I do MD5 sum again for file 0. Let's compare the hash. So now you can see the hash, two hashes are totally different because the content is different. Actually, you only need to change one bit of the content, the hash will be totally different. So now at least we answered our first question. Say if we change content, MD5 sum, whether it will change or not, definitely yes. Next, let's look at something else. Like for example, what if I rename it? What if I change metadata information? Let's first to do rename it. So let's move file 0, rename it to file 1. Okay. So now in this case, the file is called file 1, and then the content of file 1 exactly as before. Welcome back. Now we do MD5 sum again for file 1. If you compare file 1, this line, the 128 bits, compare with this one, because their content are same, the hashes does not change, even though the file name is different. The file name, one is called file 0, one is called file 1. The name is different. Okay, the reason is the name is not inside of content. MD5 hash only look at the content. The name is saved at somewhere else. We will talk about that in the later lectures. The name information is not in the content. Let's try one more thing to modify some metadata. First, let me look at what is the file 1's metadata. So we'll do ls-l, and this file 1 has the permission of owner is read-write, group is read-write, and other is read only. So let's change permission. Okay, if I change permission, use change mod, and I say other, add write, because other character is only readable, to a file 1. Let's do ls-l again. Actually, you can use the up arrow to find that. Okay. So now it's readable, writable. For file 1 now, we changed permission. Okay, changed permission. Let's do a MD5. Again, I can use the up arrow to find this one, okay, to save my typing. Now, if you look at file 1, now with this permission changed, and then here is the signature. And then before, this is file 1, before permission change, exactly same. So change permission also does not change content, because permission information is not reside in that particular data content. Okay, so what do we learn from this simple example? We should understand that hash value of a file will change if and only if the file content changes. Therefore, if you change metadata, for example, permissions, or if you change a file name, it will not change the file content of that file. By saying that, however, these changes will affect the hard drive's hash value, because both the file name and the file metadata are saved in somewhere. We will learn that later. So in somewhere of the content of the hard drive. Okay, that's all for this simple demo. Hope you enjoy it.